Okay, good evening, guys. So this is the last session for the day. Thanks for your patience till the last minute. So now I'm going to talk about infrastructure as a code. So my name is Sivaramakrishna. I joined with my colleague Satyajit. This is a crisp agenda today. What is infrastructure as a code, and a little bit of introduction or the background about OCI, which is Oracle Cloud Infrastructure. Probably if you are not familiar with Oracle Cloud Infrastructure, I'll just throw a high-level view of understanding the infrastructure. Then Terraform as an infrastructure tool, infrastructure as a code tool, a little bit of fundamentals around it, and how Terraform is supporting OCI Cloud as a provider. And then finally, we will do a little bit of demo and finally the QA, right? So how many of you have not heard of infrastructure as a code? So everybody is familiar with infrastructure as a code, right? So where exactly this word pops up typically? So when we started practicing the DevOps practices, right? Starting from the planning stage till the deployment and monitoring of it, especially when you deal with the deploy state, that is where we talk about leveraging the operations team to do their own part of infrastructure, provisioning, infrastructure configuration, and a little bit of management or governance activities around it for every release. So this is where the concept of IaC has emerged in a big time. So there are certain ways or differentiators again from the perspective of provisioning and configuration, two different aspects of it. So, and over a period of time, we could see a lot of competition has been built and a lot of tools emerged into the market, and people, you know which one to choose actually. There's a lot of R&D needs to be done to pick and choose a right tool for the right use case, etc. So this is the background story about our infrastructure as a code, where exactly this has arisen. Then what it does, what is it going to help as a typical a developer or a DevOps engineer, right? So you can treat your infrastructure provisioning or infrastructure configuration, everything the way you deal with your application development code. Probably you can code, you can version that particular component. So the way you deal with whatever the programming language, right? So you can deal in the similar fashion. You can plumb both application development workspaces and infrastructure development workspaces both together into a single source control system and drive the entire DevOps pipeline. So all sort of activities that you do as part of the application development pipeline, you can repeat the same for infrastructure. So this is a typical integral part of your DevOps pipeline. Now, which tool to be preferred? Again, here a lot of choices are there in the market, and people sometimes wanted to choose a one tool which covers end-to-end instead of getting into the best of breed from a feature perspective. So that is one thing. So this is a trade-off, typically, subjective. So there are 4 different criteria we typically deal with or in shortlisting a particular IaC tool. One is configuration management versus orchestration. What do you mean by configuration management? I wanted to have a Linux machine. On top of that, I wanted to deploy Tomcat. I wanted to deploy a couple of modules on top of it. I want to deploy an application on top of it. You can consider this as a layers, right? So provisioning of the servers is a secondary part, but I wanted to configuration on top of the provisioning after provisioning is done. That is one aspect. Whereas orchestration deals in the precursor for the configuration management. It deals with only provisioning of the services, servers. And then mutable infrastructure versus immutable infrastructure. So what do you mean by mutable? So probably once you provision the infrastructure, you don't let it subject. You typically subject it for change. So I create one VM. I don't leave it like that. I am going to create one more layer of installation of JDK. One more layer on top of it, installation of Tomcat or WebLogic, something. Again, on top of it, something patches, I apply it. So what is happening over there is a little bit of configuration drift might be expected over a period of time. Whereas in Immutable infrastructure, you can't change it. The moment you wanted to provision JDK, first you throw out the old infrastructure. Provision from scratch, keeping the end state in mind. I want JDK to be provisioned on top of my server. So keep the end state in mind and do it. Whereas in mutable infrastructure, you try to derive the end state over a phases, right? And procedural versus declarative, again the same concept here. Okay, if you know the end state, well, if you know the end state, you declaratively you mention in multiple configuration files and consolidate the view, a elephant view of that entire declarations, whether you can achieve the targeted end state or not. Otherwise, if you want to do a phase-wise, a sequential approach, get into the procedural approach. So which tool is offering this? Depends on the use case. We are going to choose the tool according to that. And some tools are client-centric, some tools require client and server component also. For example, to provide to provision Tomcat, to provision database, so some sort of a templates will keep it in the server. So as and when a client requests the server to provision a WebLogic server or a Oracle database on this particular node, the particular template will be downloaded and provisioned it. So there are certain components of client and server has to be in sync, and you need to upgrade or patch, both of them, keep it in mind. So some tools supports only client-based. I don't bother about the server concept. Everything is declarative. I'll keep it over here and just push it from the client. So the client can be your laptop. It can be any Bastion server. It could be any of gem server that you create. Keep it over there. So it depends on various trade-offs and the priorities. We choose the tool. Okay, and here is a little bit of comparison. You can see. Chef, Puppet, Ansible, SaltStack, and Terraform. There are multiple tools, right? And here is where Terraform, of course, everybody has an open source and even enterprise support contracts, especially. But when it comes to the flexibility of Terraform it is client only. I don't need to really bother about maintaining two different things, client and server component, and publishing my own modules or templates into the server, and always keep in mind of what patch level client is, what patch level server is, etc. I don't need to really bother about it. And then every time it talks about immutable infrastructure. So if you want to change it, throw out the old infrastructure, start from fresh, create a targeted infrastructure, because with this, I can get out of configuration drift, which is a pain point to handle some point in time in a production environments if you get into that. Of course, we started adopting this without any choices, but over a period of time with the invention of a lot of tools like this, we were able to choose the options, right? And for the people who are not familiar with Oracle Cloud infrastructure, just in 5 minutes of time, I wanted to conclude this. Probably you would have seen all this. There's nothing different from the conceptual perspective with other cloud providers. Some of the areas where we have our own IPs, I'll just emphasize only on that. So regions concept is pretty much similar with any other cloud providers. It is geographically distributed areas, and where we have different availability zones or availability domains, we call it as. Like they're nothing but the set of data centers with multiple fault domains configured in that, right? And high availability is ensured. All the kind of redundant components in the infrastructure is being built. Then every region is split it into more than one set of data centers. Each set is called as availability domain. So each availability domain has its own fault domains. So high availability is ensured over there, and if your application is subjected to get deployed with a high availability concept, you can configure across 2 availability domains or 3 availability domains. So high availability is ensured, and we do the seamless syncing of the metadata of this in the background to the storage or respective object storage or block volumes. Everything is being taken care in that. And then when it comes to the physical infrastructure, okay, one of the IPs what we have is non-oversubscribed network. It means that for every data center, roughly approximately 1 million network ports are available. So we don't really share the network ports across multiple tenants. So there is no oversubscription in this span. A lot of cloud providers does that. So what do you expect out of this? Is predictable latency. So, and you don't need to wait for the response for the release of the port and getting established or the socket connection, and then the context switches happens between the buffer copies, etc. So you don't need to really wait for that. And and the speed you can see, 2 into 25 Gbps speed for the interconnects between the racks. We have very high. And within the availability domain, 100 microseconds is the maximum latency. Between availability domains is the 500 microseconds is the latency, right? And no cloud providers provide the network SLA except Oracle. Today, you can check with any cloud provider. And the third layer here is the virtualization layer. Again, we have an IP here. Typically, network I/O is being treated by hypervisor. So, what it means. So between the guest VM and host VM, if the communication has to happen by the guest VM to the network socket in the host VM, right? The hypervisor play a role of switching the buffer copies and contexts. So there the lag of I/O happens majority of the time. The overhead is typically between 2 to 4%. 2 to 4% we can see it. So how to avoid this? So how can, there were technologies like single root I/O virtualizations and RDMA concepts for applications deployed on top of the hypervisor. We achieved so many things, but if I want to plumb heterogeneous network components, like be it is storage, be it is a compute, a Spark system or engineered system, anything, right? Hypervisor should never become a bottleneck for me to do that. So we offloaded that network layer completely to the, the virtualization layer completely to the network components as our own IP-based card, PCI card, something like that. Okay, that is called as off-box virtualization. Because of that, we were able to offer heterogeneous compute powers like engineered systems, XSCC, you can see, right, all sort of components, even Spark, we have even kind of storage, 3 different kind of storages, everything is possible today. We're able to plug in because of the architecture. Then, services, yes, we built a lot of native services, starting from storage services to even a couple of PaaS services like database, etc. Yes, we have a lot of native integration with the infrastructure. It is not like a layer directly running on top of infrastructure. Few of the services were directly natively integrated over there. Yes, few of them we are still working on, yeah, but offering is available. And apart from the edge services like DNS, load balancers, everything are available out there. From governance perspective, this is one of the unique feature again from us. If you want to leverage the resource utilization across LOBs within a client, within an organization, today we don't have a way to demarcate the kind of utilization or the usage, or you wanted to restrict the usage of the resources between LOBs. How to drive that today? So with other cloud providers, we need to get into end up creating different cloud tenancies. So we introduced a concept called compartments here. So let every LOB have their own compartment and deploy their own services into that compartment, and it is not being visible to other compartments or the other users in the other compartments by restricting the policies. Okay, we have a lot of governance mechanism using policies, using IAM ways like groups, etc. Yes, a lot of things is there. So with that, that is the fundamentals of OCI. Then we have seen what is infrastructure as a code. Then I'm getting into Terraform fundamentals. Okay, yeah, any query? VPC can be targeted to a compartment. It is a construct, logical construct built on top of a compartment. Like you can have you can assume this as a namespace in your identity domain. It is virtually restricted, and you really can't tweak, because IAM namespace is playing a role over there. You can't really probe it. For example, compartment A and compartment B are there. You can say the people, all the users in a particular group A can have all sort of management activities on compartment A, but they don't get visibility to compartment B. So I'm directing this kind of enforcements via policies. Okay, and what kind of resources? VPC is one of the resources. Okay, VPC is a subset under the compartment, right? We are building that embossing layer on top of it. Yeah, any resource. Be it is block volume, be it is a object storage construct, etc. Anything. No, resource group is something, a construct of grouping. Take the case of a couple of computes put together as a resource group, right? But it couldn't be anything, any resource. I'm just giving an analogy. A group of computes put together as a resource group. I can scale the group, shrink the group, right? I can deal with the entire group as a construct. But can you enforce a resource group A VM should not talk to a VM in resource group B? I still can enforce that. It is made possible. But here I am enforcing a construct, a logical wall between both of them. So end of the day, what happens is every compartment-wise utilization I can get it. I can see which department is actually consuming my cloud services. I can generate billing according to that. I can bill back to that compartment internally. Absolutely, absolutely. You don't have any limitation on that.
So Shiva, I have a point to add here.
Yeah, please.
So let's say when you're in a project development team, they have this different like dev, QA, and prod. The same way have been differentiated into different compartments, so that a developer has access only to the dev environment, whereas the operation guy and the manager has access to your QA. In the same way, the resources who are just coding, then they're not doing anything on the infra side, will be given access to a compartment wherein he can only deploy his applications. Whereas if an infrastructure team is also there under the same BU, they'll be giving a compartment which has access to create the resources. In this way, the logical separation has been done, and which we have named it as a compartment. Let's say one tenancy can have n number of compartments, depending on the capacity that they have bought. So this is the separation that we have created. Come again, I'm unable to audio.
Correct. So this is a Oracle VM. Okay,
Yeah.
This is our hypervisor is completely different again, Zen hypervisor, what we use. Okay, but off-box virtualization is a separate IP, our own innovation. We plumb that as a network construct. Okay, the entire logic that hypervisor is supposed to do while dealing with IO, network IO, is being taken out to the network, not to the hypervisor. Across the board,
Yeah.
and across the board, right? So coming to Terraform fundamentals, yes, I mentioned it is an infrastructure as a code tool, and it helps build and manage the infrastructure. And open source and enterprise variant, both are available here. And these guys support multiple cloud providers. From a Oracle perspective, both infrastructure as a service and platform as a service they cover. And even other cloud vendors, even from on-premise also for OpenStack or Kubernetes constructs, you can use this same Terraform tool. And there are two ways, as I mentioned, procedural versus declarative, right? And these guys follow the technique of declarative approach. There are two ways you can declare your definitions of the infrastructure. One is HCL, which is a HashiCorp configuration language, and second one is JSON with inference. So inference plays a role here. Probably in one file or one place, I construct something VCN. At somewhere else, I construct about compute and subnets differently. So the inference, the moment you plumb all of them put together and give you an elephant view, right? What happens? The inference, you can build it and you see, yeah, this guy is dependent on this guy is dependent on this guy, and I can predict the end state, whether it is possible or not. So keeping the end state in mind and working out it. Okay, that is one thing, the advantage of it. And it doesn't deal with configuration management. So whereas Chef and Puppet, these guys, right, or even the custom script that you write with a cloud in it. So anything you can take and plumb along with HashiCorp Terraform and join hands together to achieve a bigger picture. One thing. And from a fundamentals perspective, I just drafted a few important commands here, not there are a couple of more commands just to give you a perspective of it. One is init. This is like a CLI command when on your laptop, wherever you are keeping that client to act upon the particular target server. So you just need to invoke the init command first, which initializes the Terraform directory. So what do you mean by initialization here is probably downloads couple of modules that are required here, or the provider related content it downloads here. And if it has any other modules dependent on parent modules, it try to do the inference over there and understands that and keep that made available here. And something like that. Any kind of context that it needs to establish before working out, it does that. And the plan, a plan command gives you a perspective of what it understood out of the configurations that you made. Probably I need to create one VPC, I need to create 2 block volumes, I need to create 5 compute nodes, I need to create so many. So the entire plan it understands and give you an illustration of it, a summary. The moment you say, yes, this is what I wanted, just go and click apply, Terraform apply. So it go and executes that on the target environment. Right, and the moment Terraform is managing that environment, right? Probably at some point in time you don't want that environment. So if you were to delete that environment phase-wise, one by one, constructs are the dependent elements you need to look up and delete them in that appropriate sequence. So if you let the Terraform do that in a single destroy command, it will take it out, entire infrastructure, whatever it is managing it. Then output to show a couple of constructs are the variable values from the state files. So it maintains a state, what is the targeted state of my infrastructure. And after performing a commit or apply, what is the state. And if you are doing a delta portion of it, it compares the state file and show only one element or 2 elements needs to be added on top of it. So from the state file, it reads and outputs the commands. And the show is another command where you can inspect for a particular value in the state file. And validate is just to validate the files for the syntax verification or sanity checks, etc. Right? And especially because of the popularity and couple of plumbing of files it generates, when you are dealing with any source code management systems like Git or GitHub, right? Probably we need to add these plumbing files to be ignored while pushing it to the source code repository. By default, it is supported even in GitHub. You can see here, I can add Terraform ignore, add it to the Git ignore. You can do that. So how the Terraform code format looks like? I said it is a declarative format using JSON or HCL, hash configuration language. Using JSON, I'm just showing you here. Pretty simple. First, it is a resource, because my component is a resource. And then what is that? Provider. It is AWS or OCI, Oracle Cloud Infrastructure. You just have to give it. And what is the type? My type is virtual network. Okay, and what is my project name? Or the construct name. Sorry, it's not project, it's my construct name. The VCN name, probably a variable name I'm giving it, where int x equal to 0, something like that. That the variable name x I need to mention out here for this construct. And couple of attributes have to be mentioned here. So there are some of the optional attributes, some of the mandatory attributes that we need to figure it out from the documentation. And you can see the you can see the values over here, right? Whatever the values I'm giving here. So CADR block and compartment, display name, DNS label, etc. You can see I'm not directly feeding in the values. I'm reading it from somewhere. This is called inference. Probably I would have declared something called a variables file. I'm referring to that variables file and referring to a variable name called VPC-CADR. You can see this is what called as inference. So I will just make a look into that and plumb the value here at a runtime when I'm composing it. And then to declare the variables, there are 3 different ways. For a pretty straightforward, for a simple strings, you can do that variable and default value like a JSON format. And you can have a list values or you can have a map values. Okay, 3 different things. And populating the variables. Now, variable names probably sometimes which are confidential matters like passwords or any of the configuration entities like your cloud credentials or cloud context IDs, etc. You sometimes we don't prefer let the DevOps tool or a build tool be supplied dynamically. So when the build engine is getting started, we wanted to keep them in the environment variables. So Terraform mandates that. It gives two different approaches. One is keep them in environment variables. Let it, or whether you inject it manually or let it read from somewhere else. When the build server comes up, if you can supply through environment variables, is great. That is one way. The example is that. And the second one is you define, if it is not confidential information, probably pretty simple things. You can create a file called terraform.tf TF is Terraform. Okay, TF variables file and insert the values over there. Just name value pairs. Pretty straightforward. So confidential information, you can keep it into environment variables. Non-confidential and pretty straightforward things, you can keep it into variable file and load them it. That's it. If you have a different variable file names, probably you can supply that dynamically. That's one part of it. Then modules concept is there within this. So probably different teams are working on different aspects of it. In a DevOps, yeah, typically, which is very much evident that we need to entertain different teams working on different things. So you can build your Terraform appropriate to that particular module being developed by the team in that particular modular fashion. One thing is a pretty similar approach. Again, who are familiar with Java, right? We define a package. Within the package, we have a couple of classes. Within the classes, we can have a methods or something. So the similar kind of analogy, you can do it. Okay, well, in pretty simple words, each module is nothing but a separate folder structure where you have Terraform files. Okay, referencing it, pretty simple. For example, here, I'm creating a module called Bastion, and where is the source of it? The source is in a different folder structure here, compute/Bastion, right? And there is module definition and module name and relevant location, and you can see the name of the parameters. Each module can expect couple of input parameters that need to be published by that particular team to the other team when they are consuming it. So this is the contract between both the teams. And then you need to populate the values. Couple of values, you can see the different values that we are publishing here. One is from the variables, another one is from a different module altogether. So I can get, again, the inferences can be from a different file within the module or from a different file within the other module. So I can go to any extent from the inferences point of view. So from Oracle perspective, yes, it supports IaC and PaaS. So you need to first write the provider details first, which cloud provider and which platform is infrastructure or a platform value, and give the respective values, user credentials and etc. So what and all we have done special when it comes to the OCI provider, Oracle provider. So there are a couple of things. How to install it? Pretty simple installation. Go to terraform.io and download the Terraform installer. And you need to get the OCI provider, like a library, and command line interface you are doing it. And to connect to cloud infrastructure, pretty simple, even not only for Terraform. If you want to connect to any cloud service provider through command line API, probably you need to have an API key to interact with that. So this API, this Terraform is also nothing but a client application. So you need to set up the API key first. Do that, then define your provider or TF with IaC or PaaS, whatever the values we gave it, and just initiate it with your script, plan, understand the illustration, then apply them. So your infrastructure is ready. Pretty straightforward. And what and all we cover from infrastructure perspective, you be it anything, everything is being under Terraform provider today. Be it DNS, be it dynamic groups, be it policies, anything, or even IAM constructs, everything is possible today. We made it available. There is one more thing. What if we, and you could see this kind of phenomena with even a couple of other providers also. If we can provide Terraform as a service altogether with couple of modules pre-built, you just download the module, understand the input variables, supply them, and provision it. Where and all this will be useful, especially when you deal with the complex applications like Oracle application. Take a PeopleSoft. So deployment architecture is not pretty straightforward. I have a WebLogic server, I have a Tuxedo server, I have a database server, and plumbing of Tuxedo with the database, plumbing of WebLogic with Tuxedo, with whatever the PIAs, number of PIAs, and the clustering mechanisms I need to configure. Very, very complex to understand, right? If a module of PeopleSoft is provided by Oracle, you can download and just understand and give the input variables and just publish it. Your PeopleSoft instance will be ready in the cloud. So pretty simple. So resource manager is available today. And we have created modules for even complex applications like eBusiness Suite, PeopleSoft, JD Edwards, Siebel, etc. We have these modules. So we can make use of it. This is one of the value addition. Probably the other cloud providers will not concentrate because this is our own IP and we need to provide it to make people to make use of our products with infrastructure as a code tool. So this is the initiative we have taken. Right, before I hand it over to Satya for giving you a couple of demos, any queries? Absolutely. So I showed you an example, right? Where is the source of the module and a couple of variables. You need to supply the variables. For example, in case of a PeopleSoft, I'm telling you, WebLogic server, you understand it. One of the variable could be how many managed servers should be there in the cluster. So as an admin, PeopleSoft admin, or an operations admin, who were given these values by the PeopleSoft admin. So I need 2 managed server VM. And what is the OCPU capacity, like CPU capacity, a number of cores for a particular VM of WebLogic. So these are all the values we definitely will understand it. So we try to keep bare minimum values in the modules. Okay, we don't give a elaborated list to fill you up. Instead, you can develop your own module. So we optimize the extent possible so that you will not see the heavy lifting what we are doing in behind the scenes. Yes. Just Google it. Oracle applications module for Terraform. You can find that. But they're all public assets. So in github.com/Oracle, just go over there. A lot of content we have been publishing over there, not only from Terraform perspective, in OCA perspective, SDKs or CLIs. Every week you can see a lot of pushes happening over there. So you need to get into github.com/Oracle. There is a Terraform plugin. The first README file shows you how to install, how to practice Hello World. Hello World means in our format, a simple VCN with 1 load balancer, 2 compute VMs, 2 subnets are created, and security rules. So you need to understand the concept, right? So it will help you. It will narrate you nicely to construct this entire ecosystem and create it. So a lot of examples are available. So start with the basic IaaS and you can get into PaaS as well and even get into apps later point in time. Yeah. Right? So I'll hand it over to Satya for giving demo.
Hello everyone. I'll not take much of your time. I know you're super bombarded with all the technology right from the morning. So this will be the architecture that we are deploying through Terraform today. So once a developer writes a code on from a Terraform and then once he does a Terraform init and the plan and then apply, this is the architecture that we are going to deploy today onto our OCI console. So what we are having one VCN under which there are 3 availability domains and then a VM which and a block storage attached to it. I'll just go through the folder structure first. So this is my Terraform folder structure, and these are the files. So the .tf files refers to one of your resources that's getting created onto your tenancy. So the compute.tf says itself saying that it will create a compute, and then the the network says that it will create the network architecture around your tenancy, so on and so forth. So now I'll go through the provider. Yeah. Like Shiva said, here we need to give our cloud provider details. So the tenancy OCID, the user OCID, fingerprint, these are the credentials, or not a credential, these are the main factors that which will be authenticated with our cloud tenancy, and says there will be handshaking. Okay, I have to create in this particular compartment or this particular tenancy ID. And there's something called as variable. Why is it not working? Okay, let it come up. So the variable TF, you define all your variables that you use during the runtime. Let's say if I want to have my VM name being picked up during the runtime, I define it in my variables.tf file and the network name, and rest of the other files that you don't want to hard code, you define it in your variable.tf files. And you can see something called as TFRs. Like Shiva said, you give the value here. There are some values that will be, same across your entire operation. Let's say the compartment ID, the tenancy ID, the user ID will remain same for the your entire Terraform operations. So you define all the values here, and the default values that you want to give, let's say the numeric one, I want to create only one availability domain, I default my value here. I don't want it to be prompted during my runtime, I give it in my TFVARs. So, and you can see something called as remote exec.tf. So now, when you have your VM created and the block storage attached to it, now I want to run an IaC commands in that particular block storage. How do I do that? I write those particular commands into my remote exec.tf. So what the Terraform understands saying that, okay, once my entire infrastructure is ready, I have to go through that remote exec.tf files and then do the job, whatever is written over there. I'll do a Terraform init here. There's some lag. No, I'm connected. Pardon? New terminal. Oh, the internet is gone over. Saying inactive. Okay. Yeah, it came up here. Yeah. I'll do a Terraform init here. So what does my Terraform init do? You need to do a Terraform init onto a repository where your .tf files are there, where your provider file is there. So what it does is it will parse through each and individual file .tf, and it will parse in such a way that saying that, okay, I need to create so many resources. How do I create it? First, I'll be creating my network layer, then my compute layer, and then my block storage that has to be attached to it. So how this will happen? There is something called as internal dependency that is being defined into all the TF files. For the network, the internal dependency saying that, okay, subnets all has to be created. For the compute, the internal dependency will be saying that I have to have my network up and running, and I have to give that particular values. Let's say my subnet IP address, the public IP address, private IP address, I have to give the compute while the compute is coming up. So these are all the internal dependency that will be writing in my .tf files. So when I do a Terraform init, all these particular files will be parsed, and Terraform understands, okay, this will be my entire, steps to provision my infrastructure. Now, when I do a Terraform plan, so keeping the Terraform init in mind, what does the Terraform plan do? Your infrastructure might be spinning up one VCN, 3 compute, or it might be spinning up n number of VCNs with n number of compute. So what does a Terraform plan do? Terraform plan will understand, okay, I need to create so many VMs, so many block storage, so many public IP address and everything. So if I scroll up from the starting, so as you can see here, that there's an instance 0, there's an instance 1 here, and then instance 2 here. So the Terraform init didn't do this. The Terraform plan says how many compute will come up in this particular Terraform when I do a Terraform apply, how many compute will come up onto your tenancy, and what would be its name, what would be shape, what would be the availability domain, all the details that you have given in your compute.tf will be shown here. By this, you can again go ahead and change things. Okay, I don't need this value to be popped up here. I don't need this my VM name to be so and so. So I'll go and change. So this is like your blueprint of which the infrastructure will be created onto your tenancy. So any doubts so far? Am I speed? Am I okay? Cool, right? Yeah. So I'll not do a Terraform apply from here because I'll be going through a resource manager to do a Terraform apply. If I do it from here, there will be a duplicate because we are referring to the same tenancy. So I'll just move from black and white screen to the color screen now. Yeah, so this is your resource manager. What does a resource manager, or you can ask, oh, I'm doing everything with my Terraform black and white screen. Why should I have resource manager here? Terraform is a very lightweight application, so you don't need a heavy server. So this can be installed onto any of your production server also to run that. Just create another user, start running it. Now, if a developer wants to work on a Terraform, and scenario is that you don't want to put an entire VM on dedicated for the Terraform, what you do is you just initialize your Terraform over there, create the files, and then give it to him. And we'll give, like someone asked about the compartment, right? In that particular compartment, I'll give access to the developer saying that, okay, you create your Terraform using resource manager. So what does a resource manager typically help us doing is, you need to create a stack here. What does a stack is? A stack is nothing but your project onto your Oracle resource manager. So I'll go to a new stack here first. I'll do an edit stack. So as you can see here, there is something called as browse. You need to pull all your .tf files, zip it, and upload it here. So the resource manager internally, what it does is it will store all the TF files, and then when you do a Terraform init plan or apply from your console, at the backend it does the same job, like I've done in my Linux server now. So when I upload all the .tf files here, and then in the variable .tf, whatever the values that you had given to your SSH or .pm key files, everything, you need to paste it here, because this will not be contacting to your server. The resource manager internally runs its own VM to spin up your Terraform scripts. So you need to give this value so that it understands, okay, this is my tenancy ID, this will be my permission key, and this is my private key path, wherein I'll be copying those values. So once I give all these things, and then I'll say, do a Terraform plan. So I'll just go back to this screen. As you have seen here, the Terraform plan has given me so and so output. I'll go to the console, resource manager console, and it gives me the same thing. Whatever the resources or whatever the logs were there visible in the Linux server, the same thing have been here. So after I do a Terraform plan from here, I have done Terraform plan prior to this session because it would ideally take at least 5 minutes to come up. So just to save a time, I've already done plan precursor. What I'll do now is I'll do a Terraform plan. I'll just say plan. Over. You need to do nothing from here. Your entire VM or your entire infrastructure onto your tenancy will be started. If you want maybe another 1 minute or a couple of minutes, you will start seeing the resources coming up. So meanwhile this comes up, can we just open up for Q&A? Yeah.
So while this comes up, any queries probably we can take it up. Yeah.
Okay, so one of our team members had faced this problem. Their main issue was that Terraform cannot maintain the state of the system. So once the infrastructure has been provisioned, if a need arises to upgrade the OS or some of its components, that creates a problem. So they thought of switching back to Ansible. So do you know any workarounds for that to maintain the state?
I'll take this. Yeah. So once you provision your entire infrastructure with the Terraform, there is something called as Terraform TF state. This gives you an entire state of the infrastructure that is being provisioned. So the next time if you do a Terraform plan from that, it will not be having a previous version of the Terraform state. You can have a Terraform state of that particular or the current working directories or the current apply, but you will not be having a previous one. You can definitely get those TF state back. You'll be having it for the current session. No, you cannot get. You can get only for the that iterative, not for the back one. For the first time, you can get it.
So we can save the TF previous state.
You can do. There is a workaround, but ideally we don't do that.
So ideally, this is not encouraged.
Yeah.
That's where I came from, right? Mutable infrastructure or immutable infrastructure you want. People choose that fashion. If you are looking for a mutable infrastructure, as you said, right, one configuration change, a second configuration change, over a period of time, the drift might arise. You really can't recover from that. So Terraform always does immutable. The latest state only will be there. And if you go and modify the resources, which is actually being managed by Terraform directly, that is not being propagated back. Again, that is also a big issue. So you always have to have Terraform as a source of truth and approach to configure, orchestrate your infrastructure.
Other problem was that forget the question of maintaining state. Even if the state exists, like if a database is there, so then Terraform, if the Terraform properties file will contain that also, but it is recreating every module again and again when the Terraform plan and apply is being executed. So it is recreating from scratch every time I am doing the change, even if I'm modifying.
Yeah, obviously, because the interpolation works only that way.
That's what the Terraform plan does. You have described.
Because that is meant for that. Because the module that you were referring somewhere else, that would have been upgraded to latest version. Who knows that? I can't refer to that. So I need to take the latest one. This is where during the DevOps approach, different teams were given different modules. Probably I am front-ending, I am developing a front-ending application which is reconciling all such modules. Then I need to be up to date with the latest modules. So I can't refer to the previous state of that module. So that interpolation has to work dynamically.
So the small tweak that you can do is if you don't want to bring up that particular DB, you need to comment and then do a Terraform plan.
That is another approach.
That's another approach.
Yeah. Typically, when you go in a build server approach, right, in a continuous integration and delivery cycle, you really don't do those tweaks.
Correct.
Right.
So as you can see, my VCN has come up. That's a TF example VCN. And then my instance has come up now, like that instance 1 and the instance 0. So once this instance was 0 and 1 are completely ready, the block storage will be attached to this particular instance.
Right.
So you can see whatever the resources that are coming up. So you can download the logs and then you can refer what are the resources that have been created. Once, let's say a developer has no access to the console as well, so then he needs an IP address of what is being created, do a Terraform output. It gives you the IP address of the what they say services that have been created. Any questions? Please pass on mic here.
I have two questions. One is how are you passing the secrets? Example, you are actually executing the code from your laptop.
Correct.
As per the PCI compliance, there will be very in terms of very curious to know how the secrets are passed for connecting the virtual machines you're actually spinning up. So over the internet, when you're actually connecting to your virtual machine, I'm not talking about Oracle specifically because I got to know that you're uploading and you're running locally as if, but just take any other example like Azure in case, where the connectivity goes over an internet and you're actually making an SSH. So in that case, how are you handling the compliance part?
Okay,
Or-
so
yeah.
especially there are two ways we mentioned, right? One is from an environment variables perspective. Another one is through the variable files. Uh, and, and Terraform is chosen as orchestrator because one of the reasons is it supports only client approach. It doesn't have a client and server. If you have a server approach, again, probably the credentials might be propagated to the cloud. So in that case, you may not directly go and refer to the resource manager or here. For a generic purposes, you can refer here, but any confidential provisioning, right, where the confidential data is there, you can use your own administration laptop, keep them, all these variables populated into the environment variables through whatever the means you can do it, induce them, and there is a specific way you can define the variable name. Just tf underscore where you have to prefix it for every variable name. So it understands. It will go and filter out all the environment variables which starts with that and induce them dynamically when it is making a call to the target infrastructure. That is the only approach.
Okay. One more question, just to understand the best practices. Now, let's take about a scenario where you are building very often. I want to measure the build time. So, are you integrating with Grafana to measure that as a dashboard, or is there any other
See,
tools?
that is specific to your environment.
Use
again.
cases. Okay,
That is use case. Take a case of a functions, serverless architecture. Previous session was happening, right? Yeah, definitely I can integrate over there. And if you are using microservices approach, yes, I can do that. So it depends on the use case. It is not tied towards any infrastructure as a code tool. This is tied to the applications that you develop and getting deployed over there, and respective streams, event streams, you need to log streams, you need to push it to somewhere like Prometheus and all. From there, from that repository, you need to pipe it up towards Grafana, etc. That is application specific. It doesn't deal with any infrastructure as a code.
Sure.
Yeah, and another question might be saying that how can I do a remote, or let's say when there's a high traffic or anything, how do I use Terraform? You can just integrate with your application, and your application has to trigger to do a Terraform apply init and plan over there, and it does the job. So you can do a remote call and then spin up the infrastructure and then again come it back.
Yeah, this is what a couple of customers are doing today.
Yeah, customers we are doing it.
If you are familiar with the developer cloud service, people who developed a couple of monolith applications or even microservices, first they run the Terraform script. In the build VM, they just populate the binaries of Terraform and configure the Terraform instance against your OCI provider, and they provision the environment. Then they go and deploy over the Docker.
Okay.
Okay, and Docker installation is not straightforward again. So as you mentioned, remote exec, right? Use that, and probably you plumb your IaC protocol to mount the block volume. Again, you execute a couple of steps to create the Docker runtime on top of the Linux VM, and then you publish it. So this is all been integrated in the DevOps cycle. That's why I brought the first slide where exactly it is coming up. Infrastructure as a code tool.
Sure.
So just to conclude, you can see the route tables, the internet gateway, the security list, DHCP, so on and so forth. Depending on your requirement, depending on your use case, you can define those particular variables onto your network.tf file and then provision it.
Right? So we're around for another 10 minutes. If you have any queries, we can connect offline. Thank you very much for your time.
Thank you so
Thank you
much.
for your patience till the last minute.
Thank you so
Thank you
much.
for your commitment. Thank you.